My name is Lydia Wanjiro, and I'm going to take you through the data downloads and data processing. Let me start by sharing my screen. My name is Lydia, and for this project, I was a data analyst, and I would like to take you through the process that we went through to download the data. And for this presentation, our learning objective will be to understand data that is required to assess the lab productivity, which of course is our end product, and also learn how to download this data and how to process the data. So just to introduce, so I'm just going to build up from where the previous presenters have been. Yesterday, we had Prof presenting about the theory, and today we had Sadad, who just presented about the concepts of remote sensing and GIS. And for us to, at this point, for us to assess the starting biomass, which is now the lab productivity, from the model that has just been presented today and it was presented yesterday, we need data. And there are several parameters that are required for you to come up with the final output. And hence, when you're doing all this, you need to sit and you'd like to know where you want to be. And so you need to start by thinking what the data that is required, and then you sit and now find out how this data, where to obtain this data, and also you look at so many other parameters. So like, for example, for this project, we were trying to assess the lab productivity for 10 countries. So you also need, in that extent, you also need to look for ways, how am I going to download data for these 10 countries? And how am I going to be consistent? So you need to look for a sensor or an image that is going to cover the whole place. I mean, so you're going to use the globe or cover the sensors that cover the whole globe. And then, so for the proposed methodology and the model, so we used freely available global Earth observation data set. And these are some of the data sets that we used. We used the digital elevation model, the SRTM data, the spatial resolution of 30 meter. And for this data set, then we also downloaded the soil data. We also looked for rainfall data, and we also looked for the survey data, and also the land use data. So the question is, where do you download this data from? So in my next slide, I just copied this from our report from the table. This is the table that showed the data that we used we downloaded from. So like the first one, we have the soil data. You remember the soil data is the one that it's used. We are trying to assess the land productivity, and soil is a very big aspect. So the first one, we downloaded data from FAO. We know FAO is more concerned with agriculture and all that. So these are credible source and all those. So this is one of the places that we got soil and the parameters that were used, and also the climate data from NESA. Then you have the digital elevation model. This one we got from the USGS, but you realize for the digital elevation model, like the SRTM data, you can be able to download it, especially like previously the QGIS. With QGIS, you can be able to download it, and then from so many websites, like for example, the RCMLD, we have like they have the SRTM data for different countries. So this one is available. And then we also have the vegetation index. So this is where we had to download data for survey. Yesterday, we were presented on how the survey index was used to calculate the net production. And then we also have the land use cover that was also downloaded from the USGS. Then we have the administrative boundaries, because we have the 10 countries, then you need to have the administrative boundaries. We also had data for protected areas, population data, then drainage, and then agroecological zones. So this, as you can see here, these are the sites that we downloaded. And you can see for our case, we have even put the data that we downloaded. So it's very important, even when you are downloading data for your future use, it's very important for you to indicate the date, because your data is as good as per that date. So that's why you see from our sources here, we indicate the date that we obtain the data. So you can try visit this website. You can see it's from there. We are going to share the presentation, and you can be able to copy in this HTTP, and then you can be able to access the website and be able to download. So, sorry. Yeah. Okay, so for our study, the data we used was survey data. And as you can see from here, the survey data, the survey is, sorry. Yeah, the soil, sorry for that. It's survey study for soil adjusted vegetation index. And this is the index that we used to assess the net productivity. And we see the survey was introduced by Hoot in 1988, and it attempts to be a hybrid between the ratio-based indices and the perpendicular indices. So the reason for this presentation, we are focusing on survey data because it's the one that we used majorly. So it was the one that it was the major one because it was an index that is, it tries to factor in the soil brightness, especially when you're doing your analysis in areas that soil, like in semi-arid areas, the soil brightness is so high, so you need a collection factor. That's why NDVI, it's just like a collection of NDVI, but then use the L. If you can see from my presentation here, you can see how the survey is calculated. If Dr. Sadadi talked about the remote sensing and the band, so for this NDVI, you know, most of the time we use the red band and the near infrared band to assess the vegetation, how healthy the vegetation is. So for this one, you see we're including the L, but don't just be worried because you don't probably need to use these calculations, but when we download the data, the survey data usually come already it's already processed to this level. So also the survey data, also you can see you don't have to, for example, what she has also explained from our previous presentation, that the data we use for the MODIS data. And so you can see it's not only MODIS data that you can use Landsat, you can use Landsat 8, you can use Sentinel, but the things that you need to get to one that has the band that you want to use. Like for this case, you need band that has the near infrared and has the red. So for this, as we settled on MODIS data, and as Dr. Sadadi mentioned before, MODIS data has a temporal resolution. I mean, if you look at it, it's 1 day. I mean, in 1 day, there's a revisit time of 1 day, so you can be able to get, and also the spatial resolution, you use the 250-meter resolution, which is also good because when you're also doing analysis for maybe vegetation, because vegetation is usually a continuous sort of a data set. Like for example, if you're in an arid area, you can go up so many kilometers. So when you're considering also the spatial resolution of 250-meter, it's equally good. And even for some studies, you can even use 250 meters. But if you're doing maybe a place that is maybe a small area, that's when probably you can consider data with probably high resolution, and because that one will give you the output of a specific area. But when you're doing these large studies of maybe big countries like our data, so this one we settled on it. So we settled on the temporal resolution and maybe sacrifice the higher spatial resolution. But at the end of the day, the results were justifiable. Okay, so my next slide, I'll talk about the MODIS data. So the MODIS data, we keep talking about the MODIS data. What is it? It's the Modulate Resolution Imaging Spectrometer instrument. It's a satellite-based instrument that is continuously collect data over the Earth surface. And it's it collects information in 250 meter, 500 meter, and 1,000 meter, and has 36 bands. So there are 36 bands in MODIS. So it means that it's a very good data because you can be able, it provides measurement in large-scale global dynamics, including things like changing the Earth's cloud cover, radiation budget, and processes occurring in the ocean, on land, and low atmosphere. So you see, I've just listed the 7 birds here because actually for us, we just need the 2 birds, the near infrared and the red. Yeah. So up to here. Now, where do we download this data from? Because now this is our topic today. So this data can be obtained depending now, as I said, from when you're doing your projects and you're deciding where to download data, you need to look for things that probably, how fast am I going to get this data, and how is the process? Because if you have a big process, then it means that you probably might miss something. So there are these 2 things that you consider. Do you go the manual way? Maybe you decide to select an image. Like for example, in my next slide, I'm talking about the USGSS. This is one of the website. Actually, most of the data, this is where it's stored. This is where it fetches from. So the question you need to ask yourself, do you use a program? Like, do you use a script so that you can automate the data? Do you just go back to the Earth Explorer USGS website and try to download the data one by one? So these are some of the questions that probably you can ask yourself when you're doing such kind of a project. There are those ones that you can consider, because I'm just studying a small area, then probably the manual way, I just need probably like 2 images of a square kilometer, maybe. So that one I can settle and decide, fine, I'm just going to use the USGS, and then I can go all the way and do all the steps of mosaicing. I can do the projection. I can go all the way and do all those things. Doing so you have to choose that. So for our project, we used R, the MODIS RSTP, to download our data set. But this one, we had also explored the USGSS, and these are the steps that I'll take you through when you want to download data from the Earth Explorer. So you have 4 things that you need to consider when you're downloading your data from the Earth Explorer. The first thing you need to set your search criteria. You need to put an address of the place that you want to download data from. Like for example, if you're downloading data from Somalia, you need to key in Somalia so that it takes you to that place. Uganda, all your countries. So you need to search, and then from there, the second thing is select your data to download. The next thing you need when you go to, and also on the criteria, you also need to say your search dates, because at the end of the day, you have to have a time frame of which you're studying your data, and it has to be informed by probably your literature review or your project specification. So you need to know, like for example, if I'm using MODIS data, if like for example, a satellite started picking data in 2000, then you can't expect that you're going to get the data for the same below 2000. So as I said, so then you need your search criteria needs to be very defined. You need data from maybe 2019, you need from maybe the 1st day of January to the 12th to 31st day in December. So you need to have your criteria right. Then you have, the next thing you need to do is to select your data, and then you also need to filter out your data, and then check your results and download. Depending on how the times goes, I'm going to demonstrate just how to do it. And then you have so for USGS website, you need to register and you need to log in. And the good thing about registering here is that the same password that you use here, it's used across any website that is fetching data from the Earth Explorer. You'll use the same password. So for our participants here, if you don't have an account with USGS and you intend to do a large productivity kind of a research, please, the first step you need, because this is where you can get data to do your analysis. So the first thing that you need to register. to register. When you share this slide, you're going to, you can be able to click on them. You can actually even type it on your browser, right? And then you can be able to explore it. Yeah. So these are the things like you would do, as I had explained. This, like, for example, here, unless you choose where the country you want, then here you'll be able to see that there are different types of data. You have different sensors, and it's upon you to choose whichever suits your study. Like for us here, you can see Moody's is the one that has the indices, and we settled on the survey, and then version 6, and most of the time you need to go for the latest version. Then, yeah, so this is what I was talking about. So when you're downloading data from the USGS at the Explorer, so you can see here that once you search you put your criteria, you're going to have so many images that you're supposed to select one by one that covers the whole country. Like for example, in this case, if you select like this, when you do your search, you're going to be given all the option of the data that you have. If you choose a time frame period, then you're given the choice. Then you're given the filter, and then from the filter you're supposed to click and see, does it cover your area of interest? And if you find something that covers the area of interest, then you go ahead and download. Then sometimes as you preview, you can find that images have cloud. Those ones you can probably, based on what you're studying, then you can choose another one. So this is what I mean. You can be able to preview your data here, and you're able to know if the data you're going to get is going to be useful. But if you look at here at the USGS at the Explorer, see like the tile that I've highlighted, it covers like 3 countries. We have the Tanzania, then we have Kenya, we have Uganda. So you see, it's not covering the whole country. Like my search was Kenya, but you see, it's giving me data from Tanzania and from Uganda. So this one becomes that's why when you're choosing a method, you need to now wonder, because when you go to Uganda and get the tiles from Uganda, you're still going to get that tile that is just cutting in Uganda. You'll still be able to see Tanzania, and you'll also be able to see this part of Kenya. So you need to choose, so which other method do I need to use? And that's why there has been so many other methods that have been devised for you to download the data, so that you're able to download the data as per you download the data that suits your area of interest. Okay, so that was USGS, and I said if I get some time, then I'll be able to demonstrate just maybe 3 minutes how to download the data from the Explorer. So the next one that we used to, this is what we used for this. I'm sure sometimes when people see scripts, they get scared, but this is what we used. Modi STP. It's an R package. Maybe R is a free and open like software. You can be able to download it, install it. It's very friendly, but also you need to put in the code. So the Moody's TP is an R package allowing you to automate the creation of time series of raster derived from the Moody's lab product data. And it allows performing several processing steps on Moody's data available in a given time period. If you recall previously, in my previous presentation, we were talking about downloading data from the USGS, and that is what traditionally most of us have been trained to do. But you see, when it comes to R, why R is one that we settled for, it's because it does the processes in just do it very fast, and it combine it. So the first thing it does, it's going to, first of all, it's going to download the data, and then it's going to project the data, and it's going to even process the data. Because once you get the data, it might be in these high definition files. But you see, when you download it from the Moody's STP, you'll be able to get it in, like when you get the image at the end of the day, it will just be what you need, because it should be savvy, and then at the end of the day, it should just have done, it should have been reprojected. it should have been reprojected. So for each desired output layer, outputs are saved and a single bar raster corresponding to each acquisition data available for the selected modis product within the specified time period. So there's an installation when it comes to web, there's an installation packs for Windows, Linux, on Mac OS. So what you just need for the participant, you just need to download R. And then once you download R, then just this, we are going to share this presentation, just copy in, install the packages. You'll see the places where you can install the packages. Once you install the package, I mean, they look like, but when you just copy, install, like for example, if you look at number 11, say install package, you just copy this whole thing and put it on the code, then it will just be able to install these packages at once. So what you need when you're downloading data, you need to know which packages that are useful for you. And I say the good thing that with R is that it gives you hints. It's if whatever you want to do, it doesn't reach, it doesn't, then it should give you a hint of what it will realize what you're trying to do, and then it should give you a hint of what package you need to install. So at the end of the day, it's what we use because it worked for us. If I get time also, as I said, I'm just going to use like 2 maybe minutes to demonstrate how that is. Yes, and then, so this is the R interface. As you look, it looks like a notepad, but this is the R interface. And then we have so the good thing with it, it's that when you write the code here, you can see the moded STP here. It just takes you to the graphic user interface. And from this graphic user interface, it's where it takes you to the page that you download the data. So from here, you can be able to see that this is now how it looks like. So you'll be able to select the layers. You can be able to see from, if I'm not able to see it, you're able to, like for example, I just put in there's so many criteria that you can use for you to select the data. You can put the bounding box, you can draw from the map canvas, and you can also put like a KML or a shape file, and then it just give you so you're just going to download the data for Uganda, and then for Uganda, and then you repeat the same for the 10 countries. For the 10 countries, there may be an overlap, as we shall see. We're likely to get some sort of an overlap, but you'll be able to mask the layers. At the end of the day, you'll be able, especially when you have like for example, if you download Uganda, then you download Kenya, then you download South Sudan, you download Rwanda, all this data, and then you have it. And then you have the shape file of all the other. You'll get this data. First of all, you'll get the data being ready for each country, and then you should be able to reproject it to your country, the one that is used most. Like for example, a country like Uganda, I see them normally use 36 North. Kenya, most of the time we settle for that 7 South. So for each country, when you're downloading, you're able to define the projection. So your data, once it's finished to be downloaded, you come out with the data that first of all, it's projected. The data is in GeoTIFF, which is very friendly. Then after that, the data, it's resized. I mean, you don't have so much data to clip out. Then the third thing, the other thing that comes out that I said GeoTIFF, and then it comes projected. Because if you're going to download data from the USGSS, once you download the layers, you'll need to project the data again. But this one now, it comes like it does for you once. Once you finish the download, then you just go straight to processing your data and getting your output. Okay. So when you download the file, this is what you get. Like on this side, when you download the file, this is what you're going to get. You're going to get like composites of 16 days composite. Like for example, this one was for 2019. So this one you're going to get like a composite of 16 days. So in a year, you're likely to get how many images? You're going to get like 23 or something of the sort, because one image is 16, the other one is 33 days. That is that day. Like that until the last day of the year. So you just get a composite. So this is what you get. On this side, this is the images that you get, and this is survey. So once you get them, then you need to load them, to load the image to view them. And that's why we had the previous the way we had the previous presentation on. That's why we had the previous presentation on QGIS, because from there you can be able to view the data, and it can also be viewed from other softwares. I mean, ArcGIS and all softwares, you're able to view the data. So this is the data pre-processing. So the first thing, you already define the area of interest. When you're downloading the data, the first thing you need to do is that you need to define the area of interest. That one we've done. We know you are studying 10 countries, and now we need to have that's our area of interest, and we can't go beyond the 10 countries. So that's our area of interest. The next thing will be projecting, converting. So the next thing will be which projection is used for this country, which one is, because at the end of the day, you want your data in meters. So that's why reprojecting is very important, because you realize most of the images, when they come with the geographic coding. So you want to reproject them because sometimes you don't want to see the results in meters. So you have to, when you reproject, you need to settle for the projection of the country. And then there's something that we call tiles mosaicing. So when you download data from the USGSS, you will need to, you'll have so many tiles. Then you'll have to mosaic. And mosaicing in this case, I mean, you have to like bring the images together, you have to mosaic them. And then once you mosaic them, they need to be mosaic. The good thing with R is that then there's the resizing, and then there's a converting from HDF to GeoTIFF. So these are the pre-processing. So any data that you obtain, these are the things that you do, especially for images. Then there's something that we do again. So it's downscaling. When you talk about downscaling, you're talking to the decreasing the pixel size of remotely synced images. You see, for example, survey, like NDVI, they take the output value of survey after downloading is greater than 1 or -1. Therefore, these need to multiply by 0.0001 to scale it to the convertible values of NDVI. Remember, if you are going to interpret this image, these indexes, they count from 1 to -1. So if your images has greater pixel values that are maybe in 1,000, you need to downscale them. And then how we downscale them, they usually downscale using the raster calculator tools in QGIS. If I get time also, I'll be able to show you about raster calculator. So raster calculator is just like a calculator, just the way it's written, a calculator. It just does the algebra. Like for example, you remember these pixels are just values. They are just the values of values. So it's a value that you can add 1 + 1 and get maybe 2. The same thing that you can do a difference. You can, like for example, see when you were doing we were trying to get the NDVI. If you had the band separate, but the near infrared and the red band separate, so you'd probably need to subtract. You remember the formula we had previously. So if you had to do it like from a fresh image that is not survey, then you probably do the calculation. But then what you do it in raster calculator. So raster calculator is the one that is used to calculate raster data. Then the other thing you want to do is that you want to calculate the annual average per year. Because there are several years you're studying, maybe from 2009 up to 2019, you just need to take the average per year. So from the composite, remember the composite, the 16 days composite that we downloaded. So the moment you get those 16, maybe there are 23 images in a country. So what you do is just you're going to add the images, and then you divide by 23 the number of images, so that you're able to get the annual average per year. Yeah, so the other thing is masking out is required. So masking is basically cutting out the area that you're not interested in. So you're interested in your area of interest. So you go ahead and cut the areas we don't want using your administrative boundaries. So these are some of the things that, this is what I was talking about last calculator. If you look at it, just like science. So if you look, these are the images. You remember the images I showed you? After you download, these are the images, and then you load them on QGIS. So you'll be able to see the difference. You're able to see the different images they're loaded here, and then you just add all of them. It's just like you're adding just a normal plus, you just plus, and then at the end of the day, you divide by 23 to get an average. And then you'll get an image. The output, it's not a number, but it's an image that now has been averaged. So that's what you work with. And then after that, then you have the downscaling. Once you get the image that has been average weighted, then the next thing you do is you downscale it. You see the formula here. It's just the same way you do a formula in any other form, in any other place, like you're doing formulas. And then but the output here is a raster image. So this is the raster calculator as you see it. And then the next one, the next slide. So this is what we call masking. You see, like, for example, this is the image for Uganda, the GEO-Mik, but then you see you've put the district, like the boundary of UG. So you need to cut the areas that are outside Uganda. So this is what is called masking. So this does still part of data processing. So you need to process data so that you get the data for your specific area. And this is now when you do you downscale, you average. So this is supposed to be your output. I'm sure if you look at it, you can be able to see the values here. You can be able to see the places that are blue, green, and you can be able to see the places that are red from there. You can see the red areas there's no vegetation. I mean, it's low areas which the productivity is low. Just by looking, and it shows you these are towns. If you probably look at where this place is, it's in the towns, where they are heavily populated. They are the places where there are people. So even the land productivity there, even so, you look at the other places here, you're able to see. So just at a glance, you're able to interpret. But as I said, the theory that we learned yesterday is very important for you to interpret, because you want to understand that from -1, from 0 to -1, at 0.5 to 1, from -1 to 1, at 0.5, what is it? Like, you need to be able to interpret, and that's why the yesterday presentation, if you get ready to do this, you also need to revisit that. So as I said, the red is areas with no vegetation, and blue shows areas high vegetation after removing the soil brightness effect. So it's just like a normal NDVI, but now the soil brightness effect has been removed, and then you're able to see the productivity, because most of the time the productivity of a land is defined by how the soil fertility, there's a correlation there. So yeah, so maybe an exercise that I would like our participants who have joined the call today, I would like you to download your country models data set and process CV using any year of your choice. But maybe, because it's very useful, this is a concept. So maybe a country, it's so big, because this data takes so much time to do. It can even, depending on your bandwidth, it can even take like 7 hours to download the data. So you need to, depending on your internet speed. So I would probably challenge you to take maybe the smallest administrative unit of your area. Like, for example, in Kenya, I'm familiar with, maybe you can take maybe a location or a sub-location, and then you can be able to just do that an exercise and be able to download data and try to repeat these steps. Once you repeat those steps and you get it, then you can be able to do the large scale. Now, if you probably find yourself doing a study which involves so many other countries, maybe even more than 10 countries, but you need to have an output that is consistent. Yeah. Okay. So this is my last slide, and then maybe I can just quickly show you 3 things. I have how many minutes? I have 25 minutes, so I'm going to spend like 5 minutes for each of what I want to demonstrate. So I'll stop sharing this, and I'm going to share my desktop. But the first thing I want to show you is the USGSF. So let me stop sharing this, and then I share So when you go to the Other Explorer, you can see the HTTP here, so you can be able to type and go to Other Explorer. So the first thing you need to do, as I said, there are 4 steps. The first thing you need to select your area of interest. So you can go to the first thing you need to log in for you to be able to download data. So as I said earlier, I would encourage the participant today, kindly please ensure that one takeaway you go with that you register so that the first step is to register. That's the first thing you show interest. You register, and then you just then from there you can be able to download this data, so that once you download the data, you start your journey in now having an output like the map Sadadi showed in our previous presentation. So the first thing, you get the address. So the address of a place, like for example, let's say Somalia, then show. So it takes me to Somalia. Takes me, so this is my area of interest. So you just choose the area of interest here, and then down here you choose the dates in which you want your image is to be. So maybe you can choose, maybe you want data from maybe 2018, January of 2018 up to, maybe you can choose maybe up to today, or maybe, sorry, I did choose 2019. This. Yeah, maybe up to today. So at this point, this is where you choose your time frame. You need to identify the time frames. Then the other thing that you need to do is you choose and then also the KML. Like for example, if you have a KML, like for example, I've given you a challenge to go and download data for your local, the smallest administrative unit. So just get a KML on a Shifra, then you upload it. Once you upload it, it's just going to give you the bounding. I mean, it will give you just the area of which your KML places. You just download data and show you the result of data in your KML based on your KML. So please go get your smallest admin level and try to download data for that. Then just come with a KML or a shape file and upload here. So the next thing would be to data sets. So for example, you may be doing so many other research and probably you've settled on many of these data sets. Then you decide you're going to choose any. So like for example, you will get all the different sensors here and their data. So for us, we are interested in the MODIS data, as I said, and we are interested in indices, in soil indices. So yeah, the soil indices. So this is the MODIS. So please mark that you come here, then you come to the soil MODI, and then you're able to select here. Then you select that data set. So that is the data set that you're going to select. And I said you can select the most. Then the other thing will be maybe an additional criteria. So like, for example, we talked about MODIS and we realized that it takes images at night and also during the day. So sometimes it's good for you to identify, you want the images that are just during the day, that you just only daytime images. Maybe depending on what you are learning, on what you are studying, maybe you also want at night, maybe both. But remember, the more you choose the criteria, the criteria you choose, the more you get more results. So you can choose both day and night, and then you can now look for results. I don't know why, just a moment, yeah. Knocked out, yeah. So basically, this is how you navigate this site to search for data. And now, in the interest of time, I won't go much into it, so I'll stop sharing. And then I'll take you to our next example, which was how do you get from MODI, from the AL package. So as you can see, is the AL console. So as I said, these are the places as I said, the script there, you're just going to, okay. You're just going to enter it here, and it's going to, once you enter it here, it's just going to download all the packages that are required. So this is where you install your packages. I don't know, some reason it's, so once you do that, so this is what I was saying, the MODI STP. So once you type it, so this is the console, and this is the code that will take you to the graphic user interface for the library graphic. The script here, the library here, the MODI STP. This is where once you click on it, it takes you to the graphic user interface. So once you do the MODI STP, it's supposed to take you to this window. Once you click, it's supposed to take you to the window here. This window. Can you see my windows now? You can see the window.
Yes, Lydia, we can see.
Yeah. So once you type the MODI STP from the package, it opens this. That's why I was saying it is very friendly, because you don't need to write code anymore. You just need that code, and then it takes you to this place. So the first thing here, you just go and specify what kind of study are you doing. So for me, for us for this study, it's the vegetation indices. Then from there, you're going to choose which indices do you want. So I've chosen, do you want the 16 days, 500 meter, 1 kilometer, 1 K? I mean, you need to choose. So for us, we chose the 250 meter. So you just choose that, and then it's stellar. We are dealing with land. So aqua, it's for water. And then if you want to choose both, then the more you choose, the more criteria you choose, just remember you're going to have so many images. So the best thing for you is to just select what you need. And then after that, you have selected your product. And the product is the vegetation indices. And for this case, we are going to select survey. You just need survey. As I said, you just don't need to do remember the formula that looked complex. It's been done here. You can see already whatever you're going to get here as an output. It's going to be a 16 days composite, and it's survey. And you can see the formula there. Then after that, you're just going to do then you choose the ledge, from which dates do you want to download the data. Then you put, like I said, you remember I was telling you that you need to know the dates that you need. So you put them here. Then another thing is that you need to use, if your date is settled on where you want, then you use user defined. Then from here, this is where you change the projection. So for example, you're going to choose the EPSG code for the projection you are using. Like for example, if it's UTM-37, if you're not sure what it is, you can just type in Google, find this 32737. I mean, so these are the things that you can just put in here, and just you put it once, and then it autosave. You will still remember. Then so, and if it doesn't, then it will give you another output if you just don't type in the correct thing. Then it will tell you to select by a tile. So if you can see here, you can be, if like I'm doing a research for these countries here, Somalia, all this, then I have how many tiles? I have like 1, 2, 3, 4. Then there's Mauritius here, like almost 5 tiles. So you can decide to select by tiles. You can also decide to select by outbounding. You can decide to draw on the map. Then you can decide to load from the spatial file. Like from the spatial file, if I load maybe Kenya, it just come and give you, it's just going to download data for only this place, like Kenya. Okay, then the other thing is that load out options, save options. The output format. So the output format, so now this is where the USGS says where images are found. This is the connection, because you just need to use your username. Remember I asked you to register. So from here, you're just going to enter your name, whatever you're going to put your name, the username, unless you're going to use your password, the same one that registered with USGS. Remember, all these images are just being fetched from the same source. So regardless of the method you use for downloading the same image, you just need to log in there. Then from there, you see it gives you the output. Do you want a GeoTip? And then the output. Then from there, you come to the output, the main output folder. Then there's also the HDF, the MODIS HDF, these high definition files. So it will reprocess the data, and since HDF sometimes can be heavy, it deletes them. Once it reprocesses the data, it deletes them automatically, and then it frees you. So you just have the output only, but you won't have the HDF files. Yeah. Then after that, you just run the MODIS STP, and then you'll be able to download the data. So once you download the data, that is what I showed you previously. Okay, let me see how many minutes I have. Okay, I have 3 minutes. Okay, so once you run the MODIS STP, you haven't put the parameters here, but once you run, it's just, you should just not, maybe you'll just sleep and wait for it to download, and then you'll find your defining the area of interest, which the data that has been projected has been mosaiced, and then it's survey data. And then the only thing that you do is what you're about to do next. So let me stop share and share my other screen. My other screen is share. So this is the QGIS that Dr. Sadad. So once you have downloaded the images, now they're saved in your folder, and you have written them as survey. As I said, for the case of our area of study here, which is Kenya, which is my area, the data is found on the, I'm sure the data is, it's on the, so this same data that it's available on the portal. It's available for this session. It's for Kenya. So the first thing I do, this is the data. This is the data that has been downloaded. You can see it here. Can you be able to see it here? This is the data. I had already added it here. So this is the data, and you can see date 1. So this is the composite for the first day. Then 17 days. I said it's a 16-day composite. Then 33rd day. Okay, then 49, 65, like that, until you get for the whole of the year, until it stops, because it's 16. So this is the data. So this is how you'll see the data as it is. So the next thing that you need to do, as I said, you need the average for each year. So the average for each year. So you need to do the raster calculator. So the raster calculator is found here. You just go to raster, then you go to raster calculator, and then the images are here. So as I said, you're just trying to get the average. It's a simple mathematics, like you add all the images and then you divide by how many they are. So the first thing you do is you add the first image, and then there's a plus here. Just do like that, another plus, like that, until the end. If I do that, yeah, maybe I'm going to spend more time, but I had done it before, and I had saved it somewhere. I had saved saved it on my, so just going to, all of them, they're added here, and then you need to save them. You need to save maybe average rated. Then I save them. So you can be able to run. So once you do the raster calculation, just close there. So once you do the raster calculation, this is what you get. This is what you're going to get. So I'll just close that. So we only have one image. Remember the other time we had 13 images, but now they have been combined, and now we have an average. So this is what we get here as an average. Yeah, so this is our average now. And you can be able to see let me just put here up. So you can be able to see the values here. And as I said, the pixel values here, we need to downscale them, because you remember in DVI, survey, and all that, they measure from 0 to, they do measure from 0 to -1. So you need to go back to raster calculator, as I said, and then you take the there and then multiply by the factor. It's just the same that you do a calculator, then you multiply by 0.001. Then you save your output, and then once you save your output, you're just going to get whatever you get here on the side. You can see the one I got here is the scaled one, and then it has up to -2. So when you see these values, you're able to know that fine, now I'm within my ranges. I'm within the data that needs to describe that it's -1. It's from -1 to 1, yeah. So you're able to know that you're within your values. So the other thing that you need to do is that this data, it looks very. So another concept that I said was yeah. So we need to mask. Yeah, so we need to mask, because obviously for someone who knows, this is how Kenya looks like. So if you're assessing the land productivity of Kenya, you cannot use these other countries beyond here, because obviously you'll be overlapping with other countries. So the next thing you do is that you need to mask this so that you only get the data within the county boundaries of Kenya. So the thing you do, you just go to last term, then you do mask bit by mask, then you just, so this is remember it's the one that we have done the average is what we are dealing with, and then you just use the boundary, the Kenya boundary to run, you mask it. So immediately, yeah, so now you're able to see, now we have the data for Kenya. So this is the data for Kenya, and then the beauty, as I said, when you downloaded it, so if we had downloaded from USGS, now we would have come, done the reprojection, do all that, but now this one cuts the whole process. So the next thing you just need to, after you clip, you repeat this one for all the countries. Then properties, then I'm just going to do, because we automated the process in the model and the plugin and all that. So I'm just going to just do a random. I wouldn't even change anything here and just say apply. And then let's see if it makes sense. For people who know Kenya, so this would be your land productivity. Okay, I haven't put, so you see, you can be able to see the areas. I'm sure you can see this is area around Mount Kenya. And if you look at this side, you can be able to see these are areas that are in the, by just looking at it, you can just scan through and see that there are areas that are less productive, and we know our northern side of Kenya is not so productive. And then we know this area here. So just by looking at it, you can be able to run and see if you are getting somewhere. And then now from here, you can be able to now customize it so that you're able to do the interpretation, so that you're able to say, so that you put this palette in a way that it's low, high production, medium product, it's low productivity, high productivity, and those are the parameters that you saw that final map that Sadali showed. Yeah, I just have 1 minute left, and that's the end of my presentation.